Hello, and welcome to episode 0 of Nick and Martin Learn Stuff. In this video, we go through the first lesson of Fast.ai's Practical Deep Learning for Coders course. This is a video of our first time streaming, and naturally, we ran into a few audio issues. So feel free to skip ahead using the timestamps in the description, or just stay here for 38 minutes of lo-fi goodness. Hello, hello, hello. All right. Can you hear this? Can you hear me now? I hear myself. It's the lag though. Like, mute your
audio device. Maybe you replaced it with your original one. Oh wow, you're back! Congratulations! I can hear you. Yes, can you still hear me? Yeah, you can still hear me. And yeah, still there. Yep. Yes.
Hello.
Hello.
All right, I think we're good.
Really? So wait, now I'm gonna double check in the stream whether we can actually hear both of us. All right, watch out. Let's talk something and unmute. Unmute. Okay. I don't know if you were talking. The stream is lagging quite a bit behind. We're still at a touch of crazy scrolling around currently in the stream. Oh wait.
Hello. All right, I think we're.
Oh, you're back! It's working. Wait, but am I still? Tick, tick, tick.
Good.
Really? The way. Wow! Wow! We did it. The stream is lagging quite a bit. Nice.
Nice. All right.
So,
How long did it take? It took us 40 minutes to figure out audio.
wow. So everything, right? All the beautiful introduction that we did. Well, Chris warned us, but now he didn't warn us about audio issues. So just saying, helpful. I show you audio for anyone who never watches this, obviously. I show you audio and a couple of nice guides. What was the trick? What actually brought it back? Like what brought yours back?
I changed the inputs on Zoom. So now OBS is using a different input than Zoom is using.
Okay.
So Zoom is using the Yeti microphone, and then OBS is using I Show You.
Cool.
So, all right, that was exhausting.
Great. So, shall we start this again? Does anyone care?
Let's give the people what they came here for.
Right. Let's do some machine learning. Even though I saw in our chat before I closed it that someone came for the machine learning but is staying for the locks of hair, so I guess they're getting
that was I think Chris for We Are Hazard. All right.
Okay, let's try this again. Hi, I'm Martin. Now you can actually hear my voice for the first time, and this is Nick. But you heard Nick talk into the void before, and our plan is to learn a little bit of machine learning together and stream our process for anyone who's interested to join in and, I don't know, learn with us, or I don't know, whatever you want to do. Chat. Okay, right, and cool. The course that we're going for is from Fast.ai, which is a library built on top of PyTorch. And I've heard a bunch of good things about this course and have been wanting to do it for a while. And we're going to do it and mix up for it. So we did a little bit of setup before, and now we're back to this and are getting started by doing a little revisit on working with Jupyter Labs with actually, because I think I was talking about that before, in case anyone watches that. You get there by reading through this. And then I think, what did we click? I already forgot. But
We
I
were doing
started
the first, was it through
Colab.
Colab?
I think maybe I clicked on this because they're hosted using Colab.
Yeah,
Right. Yeah.
and
I
this
opened
is
that
where
up.
this is where we realized that we couldn't hear you.
Right. Okay, so using Colab, Colab is an online environment for hosting notebooks. It's a notebook server and actually also does GPUs, which is going to be useful for the course, I assume. And that's why I also, yeah, I don't know, maybe we can try running it on our CPUs and see what's the difference. But we went to this, clicked on Introduction to Jupyter Notebook, and here we are.
Cool.
Ready to go. Okay.
All right.
So what's the last time you used Jupyter Notebooks, or is there anything?
When did you stay at my house?
Wait, it was like
5 years ago?
it was actually 5 years ago, huh?
Something
4 years,
that.
something like that. Okay.
Yeah.
All right. So I guess you should actually do this then, and I should just watch. Can we make a switch of the screens?
Sure.
Because it makes more sense for you to get into it.
Yeah. So you were on. Can you just post that in the Zoom chat? That
On the
link?
first, sure. I can actually post it in the Twitch chat, maybe.
What?
Let me see. What? Do you have it open or?
I do. Yeah.
Okay,
I have
cool.
the stream
So,
chat open.
can you just open the chat, or do you always have to see the stream also?
I don't know.
Okay. Anyways, it's there.
Cool.
So that's the first one, Jupyter Notebooks. This is in chat. Okay, cool.
All right.
And but I don't think you're streaming that now, actually. Are you?
Yeah.
Okay. But I thought I saw my face, but maybe that was just because it's lagging a little.
Yeah, it's lagging a little bit, but we're back. Like you see, whatever I'm.
Whatever you. Okay, cool.
All right. So what are we doing? Is this just an intro to Jupyter Notebooks?
Right, that's for getting you back up to speed with using Jupyter Notebooks.
Okay. So you can read this tutorial. We strongly suggest reading it in a yes. Okay. Able to actually try free commands with introduce here. Let's build the basics. What is Jupyter Notebook? All right. Well, a notebook is a document made of cells. You can write in some of them, mark down cells, and perform calculations. Okay.
Okay.
Run anyway. All right. Cool.
One nice shortcut is command enter for running it.
Okay.
I want to click the button.
Yeah, if you don't. Okay. So, yeah, makes Jupyter Notebooks ideal for experimentation. We could see the rationale for each experiment, the code results. Okay, cool. So everything is mostly in everything's in Markdown for the most part.
Yeah,
Markdown and code.
Yeah, that's mostly what. And you can click on all the text too, and you see it's also a cell. If you click on anything that's written here, just click into it somewhere onto the directly on there. Yeah, and then you can edit that. Maybe you have to double click to get in.
Oops. Yeah.
Right. Yes. So that's just the text cell, and this seems like Google Colabs even have some sort of like editor features that the Jupyter Notebooks don't have directly. Yeah, Markdown. Right. Cool. And so you make a code cell or you make a text cell, and you can run your code in there.
Oops.
I was like, oh, what kind of math operation is that?
Cool. And then you can
save
right,
the notebooks, and I think
list,
Colab
yeah.
has something. I think it works kind of like Google Drive stuff, so you can actually save a notebook to your Google account if you go and save somewhere there.
Yeah, here.
Copy to Drive. There you go. Yeah.
All right, so let's look at the code because that's, I think, more interesting. So we can keep the results of our code within the notebook and share them. Okay.
All right, they're already starting using some Fast AI.
Yeah.
Vision.all. Fast AI Vision.all.
Where does it? So. From Fast AI. How does it
where
know,
is that?
Yeah, how does it know it's importing? Like, are there?
I think there's actually at the top. If you go to the top of the notebook, I think there was some sort of code: pip install fastbook, fastbook. So yeah, I don't know. That's some. I guess that's maybe. I don't know what. I guess fastbook. We could check it up. Fastbook is probably a PyPI package that is related to this course. Fastbook.
I think that's just what we installed. No, under Fast AI / Fastbook. Is that not this?
Fastbook. Yeah. Okay. So exactly. Yeah. It's just a library that contains all the different packages that are required for this that they published on PyPI. So we're just pip installing that into the environment there, and then you can load all the Fast AI stuff that are, I guess, related to this tutorial. You can go to PyPI and check. I don't know. I'm trying to be too educational here.
We're the ones learning, Martin.
Right. Yeah. Forgot. Okay.
All right. So, creating a notebook. All right. Yeah. So just new Python 3. So so this whole course we're basically just doing it in the Jupyter notebook. And maybe we can even copy this to our own, like, Nick and Martin Learn Stuff Google Drive and put that link somewhere.
On the ones that we're actually working on.
Yeah. And have that public. So we could do that for the one person who's watching this, which I'm assuming
I think that's
Martin.
me.
Yeah.
Oh, no, it's not me, actually. I'm not in there anymore.
Oh. It's probably
so
Chris.
Anyways. Yeah. Hi. Okay, cool. So yeah, notebooks essentially. I think the important stuff is you have code cells, you have text cells. The code cells you can run with Command Shift. You can type any sort of Python code in there. You can even do like the first, if you go up to the top, actually it's a bash command, right? Like the pip install. So you can run bash commands also right in there with, you just prepend them with an exclamation mark, and then you can run bash commands, and then usually it's Python, depending on how you set it up. But I think these are all Python.
These seem like they're move this here. Oops.
Okay, nice. They just published a package. Smart. I like it. Okay, so then let's do chapter 1, right?
Let's do it. So, okay, so this was the introduction, writing, modes. No, the chapters aren't in here. Oh wait, what's this?
This is just that one notebook, yeah.
Oh, okay. All right, where are?
We can switch. We can hand back over if you want.
Yeah, go for it. You can share.
Here we are. Back to this, and I'm gonna start with chapter 1. What's this? Need it. Oh, did you join the forums yet?
No, I did not.
Okay, so I think there's a link somewhere.
Yeah.
Forums.fast.ai. Yeah, you might need an invite link, but I'm not sure. Probably not.
I'll try it.
Okay, pip install fastbook again, import fastbook setup book. So that's going to be the little piece of code that we run at the beginning always to set it up, and then import everything. So I'm going to have to run this so that we have the code accessible. Maybe, I think you can maybe, I'm not sure. I think you can somewhere decide what type of machine this is running on. Like, like if you want a specific GPU or something, you can decide that somewhere in the Colab once.
Okay. Maybe I can set up the gaming computer I have, and we can run it on that GPU.
Yeah, it would be kind of fun to run, to run it locally. Go to this URL in your browser. No, I think we're here. Is it? What happens when I go to this URL in the browser? Okay, Martin learn stuff. Huh. Google Drive file stream. Okay, copy that code. I'm not actually entirely sure what I'm doing here. I need to enter an authorization code, maybe for the Colab to be able to access my drive and then save to there. Yeah, interesting. Huh. So did you see that, Nick?
Sort of. I was listening, but so what happened?
Okay. So when I did the import at the top, it kind of stopped at some point, giving me a link, and then I had to do an authorization to my Google Drive, which I guess is where it's going to save the notebooks to.
Okay.
So you get an authorization code.
Yeah. So if you go to Nick and Martin Drive, it should be under content. Oh no, maybe I guess under content G Drive.
Yeah, that's probably
I guess it probably.
Or maybe that's maybe content G Drive is the base folder for Google Drive anyway. It could be. You could check it out.
Yeah, I'll check it out.
Okay, I'm gonna import. Interesting setup. I wonder what this does in the back. Okay, this is how you make a new one. Can I use shortcuts here?
No, we got nothing in our drive.
Maybe I need to save it first. File. Open. Save a copy in Drive. I'm gonna try that now. Dry. Dry. It's all dry. Okay. So, and I just made a copy. It just opened up a copy for me. That is now hosted on my drive, though, it seems.
Okay.
But it might be my drive. I don't know.
Oh, that's yours. Yeah.
Yeah, okay. It's weird though, because the authorization code I took from the.
All right. Well, request access here.
Okay.
I don't know. Where did that send?
I don't know. All right, whatever.
I feel like that sent it now to you because you're signed in on your thing, on your.
I mean, it doesn't really matter, does it? Like,
no,
I mean, I can try
really.
to, but that's just because I saved it on there. Yeah. So I should log into my drive here, maybe. It's still gonna send me a request for authorization, I guess. No, it doesn't.
No.
Okay.
Cool. So now copy that to Drive.
File. Save a copy in Drive. Now it's making a copy. We've got 3 versions of this notebook already around.
Yeah. All right. Well, it's in our drive now, so that's fine.
It popped up?
Yeah.
You see it?
Yeah.
Okay, cool. So then let's work with that one, right? I'm going to close these and we're just going to work with ours. Okay, let's do this again. Import. I wonder when it's going to give me this this code thing again. I'm still not quite sure what that was about. There it is. Go to this URL in a browser. Redirect, email, HTTPS, blah, blah, blah. Look at this long URL. F drive, read only. I guess it's got all the parameters of what access I'm giving it. Google Drive file stream. What is that? Google Drive file stream. This is actually not a link. It's weird. It's not. It says it's a link, but it's not actually a link. Like, if I copy, I don't get anything.
What was that? It was a Heroku app.
Where do you see that?
When you copy that into, when you paste it into the
Drive.
Oh, weird.
No, that's nothing. Okay.
I think you just copied the word drive.
Yeah. I think that's what I did.
Yeah. Hover over it, like, no.
Well,
something's happening.
Let's figure out what this link is. Where does it go to? Google Drive file stream feedback at google.com email address. It's not actually, it's click prevent default to data destination, click allow will redirect you back to the application. Okay, but we're not learning what Google Drive file stream is. I shall allow you.
Yeah, I thought you've
tricked me long enough. Here's my authorization code. Is that like a bad thing to stream your authorization code?
I don't know.
It probably is, huh?
Probably. You know what though? If someone's patient enough to get through an hour worth of our stream for an authorization code to an intro, Python notebook for this, which is very popular channel,
right? To a channel,
they can have it.
Yeah, makes sense. Okay, so we got this chapter intro. Doesn't actually do anything. Does it do something on the original one? I wonder what that includes. Okay, we got Fastbook.
All right.
It's not even, we don't have a namespace, so I don't even know how to look for it. Let's look at that. Oh, look at that. Adam. Fastbook.adam. Fastbook.adam step.
Adaptive pool. Let's get through
add mask codes. It's we got to do that for COVID reasons. Okay, so now I show you how you can delete a cell. You click on you can actually do it with you can do it with X. If you just press X. No, you can't. Wait, escape. There's these two modes. It's like Vim. Yeah. There's this two. No, I'm trying to. Okay, so if you just select it, then you should be able. You can't do that. Okay, you have to press that. So in Jupyter Notebooks, you can press X and then it just takes it, snatches it. Okay, your deep learning journey. Hello, and thank you for letting us join you on your deep learning journey, however far along that you may be at the very beginning. In this chapter, we will tell you a little bit more about what to expect in this book, introduce the key concepts of deep learning, and train our first models in different tasks. It doesn't matter if you don't come from a technical background. That's okay if you do too. We wrote this book to make deep learning accessible to as many people as possible. Beautiful. It's for everyone. A lot of people assume that you need all kinds of hard stuff. Those people are wrong. Remember that. This is a list of, I'm confused, of a few things you absolutely don't need. Okay, what you don't need. What is this? Why is this formatted so weird? Don't need truth. That's supposed to be I'm confused. It looks like it should be a table.
Yeah.
Okay, wait, just interested also, do we have the same, is this course for me? Ah, look, there it is.
Yeah.
Yeah, okay. Okay. Deep learning has power, flexibility, simplicity. That's why we believe it should be applied across many. So they have actually pretty nice, I think I told you this, but they have like really nice student stories of people doing interesting stuff with after learning like, some deep learning with this library.
Okay.
Everyone out there, you should go and check it out.
Again, I think because I'm watching my own stream, we're the one.
Yeah, I know.
But whatever.
So,
or maybe it's Justin.
No, he would have already said hi in the chat if it was him.
It's Freezer says that the video won't play because of Twitch.
It's what?
In the chat, user, it's Freezers.
Freezers?
Anyway, continue on to your Fast.ai tutorial.
Sorry, I just messed up some light here.
All right, so in this, all right, so we are using PyTorch.
Mm-hmm. We've completed hundreds of machine learning products, used dozens of different packages, many different programming languages. At Fast.ai, we've written courses using most of the main deep learning and machine learning packages used today. We spent over 1,000 hours testing PyTorch before decided that we would use it for future courses, software development, and research. PyTorch is now the world's fastest growing deep learning library and is already used for most research papers at top conferences. Works best as a low-level foundation library, providing the basic operations for high-level functions. Fast.ai library is the most popular library for adding this higher-level functionality on top of PyTorch. In this course, as we go deeper and deeper and deeper into the foundations of deeper learning, we will also go deeper and deeper into the layers of Fast.ai. This course covers version 2 of the Fast.ai library, which is from scratch rewrite, providing many unique features. Cool. What you'll learn. How to do computer vision, classifying pet photos, natural language processing, tabular data, sales by Nick, collaborative filtering, okay, movie recommendations. How to deploy models. Oh, here's your random forest.
Nice.
Affine functions and nonlinearities. There's random initialization and transfer learning. Transfer learning is the fun stuff where you can get things to paint in the style of someone else. I think. No, wait, that's, yeah, I think that's transfer learning. Okay, stuff.
Cool, so we're going to learn a lot.
We're going to learn a lot and we're getting started. Lessons, your first models, lesson 1. Ooh, we can watch some videos. Or some video?
Yeah, let's do it.
So, hello everybody and welcome to Deep Learning for Coders, lesson 1.
Should you watch this and then learn how to route your audio from?
No, I think it's good.
This is the fourth.
I'm adjusting the volume for you.
Okay.
So that it doesn't like...
year that we've done this, but it's a very different and very special version for a number of reasons. The first reason it's different is because we are bringing it to you live from day number 1 of a complete shutdown, or not complete shutdown, but nearly complete shutdown in San Francisco. We're going to be recording it over the next 2 months.
It's really long.
It's a very long video.
I'm in the midst of this.
Should we skip through?
There's no timestamps on that, right? No.
On what?
On the video, there's no like... I don't see any.
No. Doesn't look like it.
Is this the entire lesson 1?
It's this guy's talking about it, it seems.
Can you X out of this? Like make it minimize this?
Transcript. We can also look at the transcript. Questionnaire. The questions below are the same of those in the book from one included detail. Or I don't know, maybe it's also just everything in there. So this was the introduction. Wait. Neural cells. 6 cells hidden. What's going on here? Okay, so this is some information. How to learn deep learning. There's a lot of reading in there.
Yeah.
There's the next one is your first model. Okay, so I think this is.
Yeah, let's open that. Let's do your first model.
We will teach you how to do things before we explain why they work, because we're not watching the video. Actually, training an image classifier to recognize dogs and cats with almost 100% accuracy. To train this model and run experiments, you will need to do some initial setup. It's not as hard as it looks. Do not skip the setup part, even if it looks intimidating. Especially if you have. Okay, yeah, let's do that. Sounds good. Getting a GPU deep learning server. To do nearly everything in this book, you need access to a computer with an NVIDIA GPU.
Are not fully supported by the main deep learning libraries.
I
don't think I have an NVIDIA GPU.
No?
I don't think so. You used to have 7 of them.
6. There was only 6.
6, okay.
Sore topic.
He still has them, or not? Or
no, they're
no,
gone. They're gone.
Okay. Oh, the good old days.
So we don't recommend to buy one. In fact, if you already have one, we don't suggest to use it yet. Setting a record takes time.
Do they recommend buying 6?
I haven't seen yet. I can search for 6. So GPU is a graphics processing unit, blah, blah, blah. We know that. Instead, running your first notebook. Okay, maybe we already did that. No, I don't want to run all of these cells.
I'm going to send this link to Gilad.
Which link?
This stream.
Oh. Yeah, maybe he's going to chime in. Okay, so first training, capturing results from the first training. Click me. I already clicked you. Import everything. So I think this is already, wait, this is maybe doing it. Is this doing it? Running your first notebook. Labeled by chapter, notebook number. In order they're presented in this book. Organizing learning content is so messy. Because I find this kind of like hard to follow, but it's really hard to make a good structure. But you know that. So you were using this notebook. Am I talking too much?
No, you're good.
Okay. I guess dog and cat photos. To do this, you'll be downloading a data set of dogs and cat photos and using that to train a model. Okay, yes, simply a bunch of data. Our data bunch is cats and dogs. Just click on it. Here's the notebook. Yeah, we learned that just before. Click on the cell. It begins with the line, click me to select it. Comment in Python, so it's ignored when you're executing the cell. The rest of the cell is, believe it or not, a complete system for creating and training a state-of-the-art model for recognizing cats versus dogs. So let's train it now. To do so, just press Shift on the keyboard and press the play button and the do button and wait a few minutes while the following happens. A dataset, so this is happening at the moment. We can watch it, look. What's happening? A dataset called the Oxford 3T or IIIT pet dataset. It contains
a lot of images of dogs, over
7,000
37 different breeds, will be downloaded from the Fast.ai.
Collected to the GPU server you're using.
It seems like it's going to take a long time.
Pre-trained model that has already been trained on 1.3 million images using a competition-winning model will be downloaded from the internet. Pre-trained model will be fine-tuned using the latest advances in transfer learning to create a model that is specially customized to recognizing dogs and cats. First, the steps need to be run only once on your GPU server. If you run the cell again, it will use the dataset and model that have already been downloaded rather than downloading them again. Let's take a look at the contents of the cell and the results.
All right.
I don't know what this little symbol means to them. I've seen it before. Maybe it's like, look at the cell now.
Yeah, maybe look at the code.
Mm-hmm.
Okay, so it downloaded, I guess it's that second. The third progress bar looks like is that the training?
Epoch, train loss, valid loss, error rate, time. Yeah, but we don't have any numbers there. Maybe these are the numbers.
On the bottom, yeah.
So this is, so it's the sixth epoch of 92. Does that make sense? Then we have maybe train loss, valid loss, error rate. No.
No. I don't think it's in the right order. Because...
No, I think this is maybe the time that one epoch takes, like 1.4 minutes. Would it be in minutes? Not really. But yeah, that's going to take a while. We're on 7 out of 92.
Yeah. All right, so let's keep going down and see. And then it's got to do the other one too. So actually go up for a sec.
Which other one? You mean this fire? Whatever that is.
I think it's, so if you go up, one set, the first, yeah. So
will be downloaded. That already happened.
That happened.
I guess. Oops. Pardon. All right.
Yeah. So pre-trained model has already been trained, and will be downloaded from the internet. So number 2, it seems like that's not happening at all. And then number 3, the pre-trained model will be fine-tuned, which is
maybe look. That was the downloading. That already happened. ResNet. That's the model. ResNet is some kind of model.
Yeah. It's just weird that there's 3 progress bars. And
yeah, what's that one about?
I think the last one is training the model right now.
Yeah. Let's look at the code, though, while we have the time, right?
Sure.
So we're importing this stuff, untarring some pets images. Oh, using path-lib. Okay, define is cat x, return x, 0 is upper. So there's some lambda function. No, it's not actually, it's define. But it's just in one, written in one line.
Yeah, it's just written in one line. So I don't know what x is, what it is.
x0, so
it takes something. Where's it getting called? Yeah. So is cat anywhere over there? No.
Right. Get image files, label function there. So we're passing the label. So it's labeling, I guess.
Yeah.
If it's a cat, return something. We don't know what x holds, but it's taking the first position of x and uppercasing it. Maybe it's the name of the cat. So an uppercase name of the cat. If label function image data loaders dot from name function path, that's going to be the images. Get image files, that's another function that takes the path, so it gets probably just the image files out of there. I have no clue what that is. Any guesses? Valid PCT?
I don't know, valid %, maybe some sort of like I don't know.
Yeah, okay. Seed 42, I think that's just a random seed, right? So that it's reproducible.
Yeah.
Label function is cat, so then it runs this one, which just takes number 1 and uppers it, and then I have no clue what that does. TensorFlow MS, TFMS. That
I don't know. What
resize.
TFMS is.
Resize. Maybe it's like putting the images in a certain, like, so that they're all the same size. Could be. Just guessing. Learn. CNN learner DLS. That is this image data loaders. Huh. Okay, so this code just takes the images from the data, from the source, and labels it, I think. And then this is the learning function that takes in the learning model, ResNet, and the loaded images. And that's it. Fine tune 1. Yeah. Okay. Fair enough.
So it's running fine tune.
You think? Yeah, it's running. Yeah, exactly. That's what it's doing. It's running fine tune on the CNN learner object that we have up there. Yeah.
Cool.
And that's using. Okay. Right. So you want to see the exact same results. We have to wait a bit more. This book sidebar. This book was written in Jupyter Notebooks. We get it. That's what we saw before. That's the Intro to Notebooks one, I guess. What is machine learning? Just some more info. while you wait. And sidebar. This is after it's done, I guess. Sidebar, let's look at sidebar again. The book's website. You will find all the code and you can try running and modifying every example yourself. Just saw how a cell that outputs a table looks inside the book. So a cell that outputs text. Always, okay, so it's just telling us that Jupyter shows stuff, that's all. Bit of deep learning. This is long.
Yeah.
Okay, wait, let me skip around a little. This is got some notes, but not much more. Look, there's a quiz.
Yeah, let's look through the quiz and see, I guess, if we can kind of skip through it.
Do you need these? For deep? So that's the quiz. Okay, it's right in there. Okay, do you need... Nick, I have a question for you.
Oh, Jesus.
Are you ready? It's a closed book pop quiz.
Pop quiz.
Do you need the following for deep learning? Lots of math, true, false?
False.
Correct. Lots of data, true, false?
False.
It's a good question. I'm not sure.
Yeah, because what is a lot?
And also because, you know, like the thing is that you can utilize a bunch of these pre-trained models that were trained on a lot of data, so that now you don't actually need a lot.
Yeah, I mean, the more, obviously, like the more data, the more accurate. The more data, but like the cleaner data, the more accurate. But I've trained a model before with not too much data. It doesn't mean it works, but you could still do it.
Yeah. Is it deep learning though?
It was an RNN.
Oops, I think you're freezing.
Can you hear me?
Yeah, you're back.
Okay. Yeah, no, it was like a super simple like RNN a few years ago. And it wasn't like a ton of data, but whatever. A lot of expensive...
I have the feeling that like generally you need a lot of data, but I think like because you can use a lot of pre-trained models, maybe you don't. That would be my answer.
So let's say true. Lots of expensive computers.
False.
True, but not your computers.
Yeah, but it's right. True.
This is the problem with the lots of data question.
Yeah.
A PhD. False.
False. All right. Name 5 areas where deep learning is now the best in the world.
Image recognition.
5. One. Okay. 2.
Speech recognition.
Natural language. Yeah. Okay. Natural language processing, I guess. I don't know if that's the same.
Deep learning. Like
puzzling newcomer programmers.
Yes. Wait, 5 areas where deep learning is now the best in the world? I don't even understand.
Text recognition, the best in the world.
I don't understand. Best at what? I mean, humans are still better at image recognition.
No, I think they're not. I think it's even.
Really?
Yeah. All right, let me check that. See. Why is it hard to compare? That's probably the right answer. Why it's hard to compare AI and machine learning image recognition. Got a nice abstract here. Look at that. Do you know what that is?
Yes.
Me too. I don't know what that is though.
Yeah, I wouldn't know what that is either.
What is that? Is it like?
It's like a typewriter or like an old computer keyboard.
But it looks like it's like a wheat
It's
grain on top of a
it's a
typewriter.
it's a cord that you can extend, like the old
Ah,
telephone.
you're right. Yeah, one of those.
Yeah.
I could say we needed 2 brain processing powers to get. No, well, maybe you would have figured it out by yourself. I didn't. Right, like to compare AI, blah blah. If an article looks like that, no thanks. Okay, I don't know, Mr. Answer. Can artificial identify pictures better than humans? I'm gonna go for another one that probably has a similar picture to start. Yes. So let's not take it seriously. But I'm still gonna look at it. 4.9 error rate. Microsoft beat its own record. This is too much text. Goodbye.
Yeah, let's go back to this very serious quiz. This make or break quiz.
Where's it? Here.
All right.
We only got 3.
That's
so
fine.
I guess we failed.
It's okay. Maybe a computer can help us with the other 2. Answering quiz questions. Search. There you go. Finding the best images for AI articles.
Finding stock photos for AI articles. Okay, well, what was the name of the first device that was based on the principle of the artificial neuron? Guess we did not watch this video, huh?
I don't know, but does it matter?
No, it's part of the quiz. Search transcript. First device.
Artificial
neuron devices actually couldn't. Same book that showed that using multiple layers of the devices.
Pointed out that a single layer of these artificial neuron devices actually couldn't learn some critical things. It was like impossible for them to learn something as simple as the Boolean XOR operator.
I think. Oh no, wait, that's the book. I think it's still perceptrons. I've heard it before.
Can you look up artificial?
Look, that's it.
The Mark I perceptron at Cornell. So that was, I think this picture was 1961. Thankfully, nowadays we don't have the Mark I perceptron at Cornell.
In 1943, Warren McCulloch neurophysician jumped up to develop a mathematical model of an artificial neuron to declare that law perceptron. I tell you, that's the answer.
All right. Next question.
Based on the book of the same name, what are the requirements for parallel distributed processing? PDP. Don't know. I'm just checking what our training is doing. It's 50% done. Okay, you got anything for me? PDP?
Based on the book, what are the requirements for parallel distributed processing? Parallel distributed processing.
Based on the book of the same name. Perceptron, I guess. So the book was called Perceptron.
What are the requirements? It looks like a lot of cables, a large storage unit, lab coat, and some pomade for your hair. I think he may have a tie.
Yeah, sure, but definitely pomade.
Yes. Yeah.
And,
I like how they included the cursor in the screenshot. Oh no, that's your cursor.
And I was just going over it.
Oh yeah, okay.
Okay, so you also need bravery to put your hands into this cable mess.
Yeah. So a lot of copper, a lot of plastic, and a bit of bravery.
Nah, no PDP.
It's all right.
Okay.
We've come a long way.
We've come a long way. What were the 2 theoretical misunderstandings that held back the field of neural networks?
The speed of which your fingers can replace cables.
I have the feeling you're not taking this quiz very serious. What's that?
I'm just saying, like, I'm just saying that a photo's worth 1,000 words, and that photo is telling me a lot.
All right, I'm gonna answer this one. It's a graphical processing unit, which is
I think we got one question right so far.
which is a device that is optimized for processing graphic things really fast.
I think our viewers on Twitch know what a GPU is.
Yeah, open an opening.
It makes you
and
play
execute a cell
Fortnite
containing
better.
1 plus 1. What happens? That's true. Yeah, I guess everyone is. Yeah. What happens? Follow through each cell, strip direction into notebook for disrupted before executing. Guess what will happen? Okay. We don't need to do that.
Yeah. Why is it hard to use traditional computer program to recognize images in a photo?
Images in a photo. Images, do they mean like specific parts of the?
Probably like a dog in a photo.
Yeah, and the dog is the image. Okay.
I don't know. I would just say that a traditional computer program utilizes CPU over GPU.
Yeah. Okay. Is it important to notice? I mean,
I think it's also like traditional programming versus like the idea of like machine learning is that the I mean, it's in the name, right? Like machine is learning, so like you're constantly like updating the logic in the program. No,
traditional is a manual process. Yeah, I think that's probably a good point, that it can keep updating. Traditional programming one has to manually formulate code rules, while in machine learning the algorithms automatically formulate the rules for data, which is very powerful. Okay, why specifically for images? I don't know. Okay, fair enough.
I think images is mostly because it's like it's trying to recognize the patterns and like the curves and trying to
what curves?
From what I remember, is like
edges.
Yeah. And then putting all those edges together to.
And you kind of like have to always be aware of the whole image, like where is what value does each pixel have or something, and how are they all connected?
I don't know. That's why we're taking the course.
Okay.
All right. What did Samuel mean by weight assignment? I'm not sure who Samuel is.
I like this transcript search.
This is probably the most time we've saved in this.
So back in 1949, somebody named Arthur Samuel started trying to figure out a way to solve problems like recognizing pictures of cats and dogs. And in 1962, he described a way of doing this.
I think this lecture is probably really interesting.
Yeah. We should probably watch it like on our own.
Yeah, it's just very long for a stream that started 1.5 hours late because we had to figure out how to get my audio working. Okay, but we can do some point also when we actually watch one together, and we can pause it and look around and stuff like that, because I think they're good videos.
Yeah.
So what was the question? Why did Samuel mean by weight assignment? Good weight assignments to use. So that's the Arthur Samuel version, right? A measure of performance is known as the loss. And the reason why is because of Arthur Samuel. Good weight assignments.
Good weight assignments, to use Arthur Samuel's terminology. Good weights. Good weights.
I can't go back like that.
Set of weights, it does a different task. And it can actually do any possible task. Something called the universal approximation theorem tells us that mathematically provably, this functional form can solve any problem that is solvable to any level of accuracy if you just find the right set of weights.
I think I went back.
Which is kind of restating what we described earlier in that, like, how do we deal with the Marvin-Minsky problem? So neural networks are so flexible that if you could find the right set of weights, they can solve any problem, including, is this a cat or is it a dog? So that means you need to focus your effort on the process of training them, that is finding good weights, good weight assignments, to use Arthur Samuel's terminology. So how do you do that? We want a completely general way to do this, to update the weights based on some measure of performance, such as how good is it at recognizing cats versus dogs? And luckily, it turns out such a thing exists. and that thing is called stochastic gradient descent, or SGD. Again, we'll look at exactly how it works. We'll build it from ourselves from scratch. But for now, we don't have to worry about it. I will tell you this, though. Neither SGD nor neural nets are at all mathematically complex. They nearly entirely are addition and multiplication. The trick is it just does a lot of them, like billions of them, so many more than we can like intuitively grasp. They can do extraordinarily powerful things.
Okay, I don't have an answer. What did it mean by weight assignment?
What's the question? What
did he mean by weight assignment? Do you know what weight assignment is?
I
kind of have some sort of idea of it, but I don't really know.
Yeah, I also have some sort of an idea. I don't know how it plays into. So with I think as it's learning, isn't it? Didn't he just said it?
I think the weights,
really
it's not necessarily as it's learning, because like you can change the weights. I think the weights are just like how strongly do you value a certain aspect of the data. Like you give it some weight, like you say, I don't know, like this edge, the edges around the images.
Yeah, I don't know if it's the data or if it's like the logic that you're saying. This we're adding we're adding a heavier weight to this. We care about this more. We think this is more important.
Like we care for, if you think of, you're thinking of some deep learning stuff or what, where you say like this path, we want to give more attention to this one neural path or what? Or
sure. Yeah.
Is that would be
maybe not a neural path? I don't know.
Okay.
I do remember playing around with a neural net and then just messing around with the weights and seeing how it affected the like stock price predictions, like a super basic model, like those example Apple stock price models or stock price examples.
Yeah, but what are the weights? We know we can change them, and it makes a difference for the output. There's usually like, I think the weights get us, that's what the gradient descent does. It adjusts the weights, right? To find the best one that gives the best output.
Yeah, so I just looked it up on Google, right? When the inputs are transmitted between neurons, the weights are applied to the inputs along with the bias. Weights control the signal or the strength of the connection between the two neurons. In other words, a weight decides how much influence the input will have on the output. Yeah. So it is with the, so it's influence on that like neural path. Cool.
Okay.
Good enough for me.
Good enough for now. What term do we normally use in deep learning for what's called weights? Oh. I thought we called them weights. That's the Arthur Samuel version. The reason why is because
that's the Arthur Samuel version, right? Nowadays we don't use quite the same terminology, but we use exactly the same idea. So that function that sits in the middle we call an architecture. An architecture is the function that we're adjusting the weights to get it to do something. So that's the architecture. That's the functional form of the model. Sometimes people say model to mean architecture, so don't let that confuse you too much, but really the right word is architecture. We don't call them weights, we call them parameters. Weights has a specific meaning, it's quite a particular kind of parameter.
Interesting. So you still use the term weights, but it means different things, and the more general one is parameters. Oh yeah. And then you got all this parameter tuning, blah, blah, right? That's like one of the things that you keep hearing.
Can you lower the volume on your computer when you play?
Sure. Yeah.
Do it again? A little bit higher?
The things that come out of the
that's good.
model, the architecture with the parameters, we call them predictions.
Cool.
And the predictions are based on two kinds of inputs. Independent variables, that's data, like the pictures of the cats and dogs. And dependent variables, also known as labels, which is like the thing saying, this is a cat, this is a dog, this is a cat. So that's your inputs. The results are predictions. The measure of performance, to use Arthur Samuel's word, is known as the loss. So the loss is being calculated from the
Where's the bias?
Okay. And then there's an update back to the parameters. Okay, so this is this.
What's the bias? Do you know? Like from what you read, like the Wikipedia thing, it said we got weights and bias.
Let's see. Weights and biases. Biases which are constant are an additional input into the next layer that will always have the value of 1.
Well, I totally zoned out. Can you say it again?
Biases, which are constant, are
Okay,
an additional input into the next level that will always have the value of 1. Bias units are not influenced by the previous layer. They do not have any incoming connections, but they do have outgoing connections with their own weights. The bias unit guarantees that even when all the inputs are zeros, that there will still be an activation in the neuron. So yeah, in this, and then
I don't get it.
The formula here, it's y.
You want to share?
Sure. Oops. Wait, is that it? Yeah.
Yes.
Yeah.
But to constant, an additional input to the next layer that will always have the value of 1. I don't. What's that supposed to mean? That it always will have the value of 1? Like what?
I don't know.
It's
Here,
just 1.
Yeah. So here it just seems like, so the bias unit guarantees that even when all the inputs are 0, there will still be an activation in the neuron. So here, yeah, even if like you have a weight of something, in this case, right, the sum of weight times if the input is 0, at least it'll just be 1. So then y will just equal 1.
Okay. And that's always 1. So the only reason for the bias is so that the layer activates, even if you're getting a 0, if you end up getting a 0 somewhere before.
That seems correct.
Okay.
Cool.
Okay.
All right. You want to share again?
Oh, yeah. Okay. Let's see where our collab is at. Ooh, 98.91.
Wow.
We're at the second to last cycle, epoch. So it's still running, or did it? Oh, there you go, 100%.
Nice.
You saw it live here first.
And then it just dropped down to 0.
That's kind of disconcerting. Oh.
And now we're back at 4. All right, so 1 of 24. All right.
Wait, 1 of...
2 of 24.
Yeah, that's a bit faster. So I wonder what it's doing, though. Like, so let's see again. So it downloads the images. Then it gets the pre-trained model. That's we said the ResNet. That's trained. Will be downloaded. The pre-trained will be fine-tuned using the latest advances in transfer learning to create a model that is specially customized for recognizing dogs and cats. I don't know.
Yeah, I have no idea.
The epochs were the fine-tuning, or is this the fine-tuning? Okay, so we got 5 out of 24. So.
All right, it's another 10 minutes or so.
Yeah. We got a couple more questions. Are these questions any useful?
Draw a picture that summarizes Samuel's view of machine learning model.
Oh, look at that.
I think, yeah, there we go. Awesome, thank you.
Wait, no, but okay, so let's think about it. So architecture, what you build, you have some inputs, you have some parameters, you get predictions out of it. Loss, what's the loss? Depends not only on the predictions, but also on the correct labels. Labels and predictions. So this is like how correct it was, the loss?
So the measure of performance is called the loss.
Measure of performance. Okay, so how well did the predictions fit the labels, I guess, right? The labels are
Yes.
the
Yeah. So then, you'll have, I guess, like a loss value, and then you update the
the parameters.
parameters, and then just keep going. Okay.
Okay.
Cool.
Draw a picture. Why is it hard to? Did you draw it?
We did draw it. Why is it hard to understand why a deep
Maybe
learning
the point
model
is that you
takes...
should actually do it. No, sorry, keep going.
Should I do it on my whiteboard back here?
Ooh, nice.
Next time. All right. Why is it hard to understand why a deep learning model makes a particular prediction? Isn't it because it's just doing all of this, like, constantly updating, and we don't really have insight on the predictions and the losses and how it's updating the parameters and what that actually means, right? Yeah.
I think it's like this machine learning, deep learning black box thing that you feed it some stuff and you let it do its thing, but you don't really know what it's doing or why it's doing it.
Right. Okay.
What is the name of the theorem that shows that a neural network can solve any mathematical problem to any level of accuracy? We had that before in one of the sections. Something. I don't.
Something. It's
really
Samuel's theorem.
It's Sam's theorem.
What do you need in order to train a model? I guess. Wait. Ooh, 100%.
You need a data set? Oh, I keep messing this up. Is it? It's starting something else.
And now it's starting something else. Go back to that.
Oh my God, look, do you see what it's starting? 0 of 92.
Go back to that other screen. Your first tab.
Yeah, sure.
I think.
Yeah.
Yeah, let's just leave it and just see what happens at the end of this quiz. What was the name of the theorem? We said Samuel's theorem. What do you need in order to train a model? You need those first three things, right? The inputs, the parameters, and the architecture.
Okay, and what translate this to some like more commonly used terms? Like what's that?
Inputs would be like the data set, right? Like a labeled data set. The parameters would be this, the idea of Samuel's weights, and then the architecture. Whatever that means, right? Yeah. And then your architecture is I don't know, it's so weird. I've never heard the word architecture before. Maybe that's something that's like got more popular in the last 5 years, probably. But yeah, it's just because I'm thinking
the
of
functional
this as like a
form.
model.
So it says here the functional form. Pointing at it, functional form of the model is called its architecture. But sometimes people use a model as a synonym of architecture, so this can get confusing.
That's how I've always like thought of it before. But I guess the model is after it's trained. Is that the functional? Yeah, I guess so.
No, wait, but the functional form is the architecture. Functional form of the model is called the architecture.
Right. So the whole thing is a model. The model is this entire diagram.
No, I don't think so. I think the model is the same box that the architecture is, but maybe like when you set it up, but before you run it. Does that make sense? Not really.
I don't know.
What's the difference between model and architecture? Quora. You can iterate over many models following the same architecture. The architecture is the global structure you want to build your neural network on. For example, you want a few convolutional layers to extract visual features from an image. Some fully connected layers, blah, blah, blah. The model is the neural network itself with specific kernel sizes, activation functions. I don't really understand. You got it? I didn't really get it. Did you get it?
I think so.
AI model can be seen as just a flow chart showing how the control flow moves, where it moves, how it moves, and why it moves. A lot of moves. However, AI refers to the next step after building an AI model. AI. This is so
I think
confusing.
the core answer was a bit more clear.
It was better formatted. That's for sure. Okay, so should I get back to that and you explain what it said? Oops. Okay. Can you rephrase it?
Let's see. So the architecture is the global structure you want to build your neural network on. For example, you want a few convolutional layers to extract visual feature. Okay, blah, blah. Some fully connected layers, and finally a softmax layer. So you can iterate over many models following the same architecture. The model is the neural network itself, with specific kernel sizes, activation functions, number of nodes, etc. It is the virtual object that you can save, load, and train, deploy or to production to make predictions on new data.
For me, this sounds the opposite of what the guy in the video is saying, kind of. That the architecture is the generalized thing, and then the model is the specific one.
It's from this. It sounds like. No, for example, you want to. It sounds like over many models following the same architecture. So it sounds like for this, you have the architecture that may be something more general, right? That would be like, I don't know, training animals. And then maybe the model would be specific to dogs or cats, fish.
Right. Yeah, and you can train all animals the same way, supposedly, whatever. Doesn't
it,
really
work. That doesn't really make sense.
This metaphor.
Yeah, it not exactly that, but I think along those lines where you could train similar things with the same architecture, but they would be trained almost like not the final, a more final version would be the model, or like the trained version of the architecture with the inputs and everything is the model.
Right.
That's what it sounds like.
But okay, that makes sense to me. I just have the feeling that this says the opposite here. Functional form is of the model is called the architecture. Maybe functional doesn't mean the one that's actually running, but maybe functional is some kind of term that talks about it being higher level.
The functional form of the model is called the architecture. Yeah.
Maybe functional is like this flowcharty type of thing. Like,
well, I think it's because this is the architecture is is like what's actually doing something with the inputs and the parameters, right? Like that's what's actually functioning. This like and then like spitting out the prediction, and then checking that to the label, you can calculate the loss. But that seems like it's more universal. This we're predicting that this is a cat, and we're saying that it's 80% that it's a cat, and then if you check it out that it's a cat, kind of calculate some sort of a loss to that.
And you only find out whether it's alive or not when you have the loss.
Or when you open the box.
When you see whether it's an architecture or model. I'm sorry, I didn't actually get it.
Yeah, I think what they mean by functional is just the architecture is what's doing the work. Doing the work specific to train this model, right?
So my understanding from the answer from this other guy was that the architecture is actually just which pieces are you using, like a high level structure of I'm using this I'm using this and this and this, and then the model is utilizing the generalized version of the architecture with actual real weights, etc. That's what I understood from the Quora answer.
So,
look what he's saying here. It's like it's a few convolutional. So I'm saying I have 5 convolutional layers to extract from the image. I have 2 connected layers and 1 softmax layer. That's the architecture. And then I can run a bunch of different models on it because they each model uses different weights on it and different kernel sizes, activation functions, whatever. But they all follow this architecture of using 4 convolutional neural networks and blah, blah, blah. Do you see what I'm saying? Or that's how I understand
yeah,
this.
I think you're right that, but it's also like the architecture can be, I don't know, you can even think of it more general than that. Like the difference between these like convolutional neural network versus like a recurrent neural network. So like that in itself is like an entirely separate architecture. I don't know if that's because that's just the way that it works, right? One works a very specific way and the other one works a very different way. And there are other, I was going to say the word model, but there are other architectures in machine learning that work differently that are better suited to train specific tasks or train for specific tasks, right? Like maybe CNN is better at image recognition, and I don't know because I haven't looked at any of this in a long time, but maybe a CNN is better at image recognition than an RNN, or vice versa, right? Or maybe they're both terrible at it and you need to do something else, and those are good at like stock price predictions. I have no idea, but that's what I think of when I think of architecture. It's this like higher level way of getting to that prediction by the way that like how you're sending the data back and forth between the neurons, that kind of defines the architecture. And then once that is trained with the different parameters and what's the other one? Parameters and inputs, then that becomes that model.
Mm-hmm.
Yeah.
So this is the architecture and this would be the model, if you want to take it schematically.
I think the whole thing would be the model.
The predictions are not part of the model, are they?
Yeah, I think so. The predictions and like calculating the loss, and then that feeds back into the architecture. And then once that's trained, I think that is the model, because then you can kind of like, add more. Because it seems like with this, right? Like once the inputs are done, then it's done, right? It's trained. You've trained this model to with these inputs, and then you can quote unquote like retrain it or add on to the training by putting more inputs, right? Or changing the inputs, or adding more inputs to this and running it. So that's my understanding, is that this flowchart is the way that it works. Once it's trained, it becomes this model. I guess this can be also seen as a model, but this just seems very like, I don't know, basic. But the architecture is what it's the structure of how this program is like moving around the parameters and the inputs and actually like sending the information back and forth and updating itself. That's what I think. I could be wrong too.
Cool.
But anyway,
fine with that.
Next question.
17. Oh wait, let's take a peek first. Still running.
We're getting these like achievements on Twitch, and I don't know what it means.
You've streamed for 1 hour without audio.
People, okay, so we got It's Happening, which is our first stream.
Yeah.
Reach 2 followers. We got that one.
That's me.
And okay.
Did you follow our channel?
I haven't followed it yet.
Oh yeah.
But the next one is when we get 10 followers. So for everyone watching this stream right now, which I think is Martin, send this to your friends and tell them they will get somewhat maybe misleading information on our opinions on machine learning.
Well, that's the point, but we're gonna work through that, right? All the misunderstandings until we have some So you
Exactly.
you have to stick there until we actually understand what this is about.
Exactly. Yeah. All right. Number, what are we, 17? How could a feedback loop impact the rollout of a predictive policing model?
Okay, I have no idea what this question even means.
How could a feedback loop impact the rollout of a predictive policing model?
Can search for policing. For example, you've built a predictive policing model that predicts.
Sure. So wait, hold on.
You've built a predictive policing model that predicts, doesn't recommend actions, it predicts where an arrest might be made. You've built a predictive policing model that predicts, doesn't recommend actions, it predicts where an arrest might be made.
I don't like the way that he says predict.
In the US
Very aggressive.
No, it's predicting that based on data and based on labeled data. And in this case, it's actually going to be using US, for example, data where I think depending on whether you're black or white, black people in the US, I think, get arrested sometimes, like 7 times more often.
So let me just see what this says. This can create feedback loops such as a predictive policing model was created based on where arrests. Oh, this is actually about policing.
Yeah, I thought policing was maybe another machine learning term.
Yeah, me too.
So what's the question?
Consider how a model interacts with it.
Partially simply reflecting biases in existing policing processes. Yeah, okay.
Law enforcement officers then might use that model to decide where to focus their police activity, resulting in increased arrests in those areas. These additional arrests would then feed back to the retraining future versions of the model. This is a positive feedback loop where the more the model is used, the more biased the data becomes, making the model even more biased and so forth. This is
I see what it's
very interesting.
Yeah, I see what they're trying to get. I think I don't know, from this it seems like you're just asking the wrong questions. So how could a feedback loop impact the rollout of predicting policing models? It seems like if you're just like in that first point, right? This is not actually predicting crime, but rather predicting arrests.
Right.
So it'll just if you reflecting biases in existing policing processes. So
yeah, I think the interesting part here is just like he's probably exemplifying how some of these models can like keep digging themselves deeper into wrong predictions because of how they're set up in the beginning, or what assumptions they're based on, which I guess is what biases are in general, right? Like that the way that you make this model run and how you set it up has a big impact on what the outcome is going to be.
Right.
And it doesn't mean it's correct just because it tells you something.
Yeah. So if the department was like, where do we, right. So it's asking the right. Model. Yeah, it's like asking the. I think it's just exactly what you're saying, like showcasing that like if you ask the wrong questions, you're just digging yourself deeper initially. Yeah. Okay.
Cool. Good, important point. Do we always have to use 2 to 4 pixel images with the CAD recognition model?
Yes.
I think maybe yes.
225 by 225, it does not get it gets more of the features and it creates a weird looking cat. It starts saying dolphins.
Wait, are you serious? No. Are you serious? No. I think it might be that we have to use it though, because it's trained on that size. Look at that. That's where the 2 to 4 comes in. I think there's something about, because it's, like it's taking the images are just like matrices of numbers, right? Of the pixel values. And I think it's using this, it's using the certain size to figure something out. And I think that if the size is different, the model might get messed up. I'm not sure though, but I would give this a yes.
Okay.
Image size, let's look for 2 to 4.
We should have actually taken the questionnaire, because they'll tell us if we got these wrong.
What's the questionnaire? The thing that
the actual quiz, yeah.
Oh my god, they have answers or what?
I don't know. I'm just...
Go to login
go
to
down.
sign up. Super Memo 2. Oh, this is cool.
Oh, wait, maybe not. Yeah.
Wait, let's do it. Nick. Password. Oh, this is dangerous again now. I should stop share. Right.
Doesn't it like just make the little dots?
Yeah, but I see it first on the, I don't know.
Got it.
So, AI quizzes.
I think Gilad is sleeping.
Yeah, it's maybe not a good time.
Where is he now? He's in India?
Yeah, he's in India.
Yeah.
I think so, at least. What do you not need? Lots of math. Look, yeah, this is much better. Oh my God. We should have done that right away. Look, it has relevant part of the lecture in there.
All right. What's the next question? How do you get to the next question? Just change it to 2 on the... Yeah.
Change what?
Click onto the next one. And then in the URL, like just go to 3.
Ah, gotcha. Yeah, nice. Are neural networks recent inventions? What year was the mathematical model of artificial neuron developed? Answer: the model of artificial neuron was developed in 1943 by Warren McCullough and Walter Pitts.
All right, let's go to like question, what was it, 19 are we on?
This is cool. Look, this has some sort of, like, you can do this with spaced repetition. You can use it as like flashcards, I think. I like that. Wait,
This is when Martin nerds out so that he can see if he can integrate any of this into his current courses.
No, it's just for learning, for myself, for learning it. Spaced repetition, look at it. They have like some sort of, I like this stuff. Period after which material needs to be reviewed, and the feedback greatly appreciated. Someone made the effort of making these cards. This is awesome. Learn will pick questions for you to review based on modified Super Memo 2 algorithm. This is like the algorithm that all this spaced repetition things use. So if you go to learn, okay, you need to confirm your email address before you can start learning.
I'll do that.
Okay, thanks. Confirmed?
2 seconds.
1, 2.
Wow, internet's really bad right now. Yes, confirmed.
Okay, reload. Okay. Look, now we have this spaced repetition. What do you not need to do? And now we can ask ourselves, what is it? We don't need to be a math genius. We don't need a PhD, and we don't need a GPU. Lots of math, lots of data. Look, hey, there's our answer. You were right.
Record-breaking results with less than 50 items of data.
Nice. Okay, partially correct. This is so much more interesting. I knew recent invention. What year was the mathematical model? They're not recent. We don't know the year. 1970 something. What's your guess?
What is it? Neural net recent invention? No, I think it's sometime in like the 60s.
Okay. 43.
40s.
Incorrect. 43. Some of the components that learn is described, a book described in parallel distributed. What are some of the components of a system that can learn? It's described in, we have weights, we have parameters, we have neurons. Oh, there's a lot of stuff. Interesting. This is cool. Very nice. Also, I like the design. What can a sufficiently large network with one hidden layer learn? Everything, anything. Any mathematical model to any level of accuracy. Okay. What is a good way to learn to play baseball? Is it by starting to learn about the physics of a parabola and learning how to switch a ball, or by watching baseball and tossing the ball back and forth? What's the better way to do it?
I mean,
Are you still with me?
watching baseball and tossing it back and forth. How does this apply to deep learning or anything else?
We should learn practically, not read the math. Which is what we're trying to do, but this model just keeps training so long.
It just takes forever.
It told us we have to wait a couple of minutes. Click me, the first character line in,
And this isn't right. Yeah, this is running.
and wait a few minutes while the following things happen.
It's been 2 hours.
Do you think it's because we cloned it on our Google Drive?
No, it should be using.
Wait. So the good thing about that this is running in the cloud is we can just start a second process and see. Right? We shouldn't slow anything down.
Yeah.
So if I go,
but it did also. It said somewhere that because it's a public, it's a free resource that, I mean, like, don't expect it to yeah.
Right. That makes sense. A popular free service have changed notebooks, so keyboard shortcuts are different and not everything works. Much of chapter 2 doesn't work because Colab doesn't support creating web applications. There's a real Jupyter notebook, so everything in the course works. It also provides space to save. So what about we do one on gradient? Paper space gradient. We have to create an account. Yeah, that looks a bit more involved. I don't want to do this right now.
Yeah.
So I'm just going to look at this again and then try that again. Okay, so we got it. But then I have to do this code thing again, right? It's probably not worth it, but I'm just interested why this is taking so long when it says it should take a couple of minutes.
Oh, for the access code and everything?
Yeah, I didn't have to put it in again, actually. So I guess it's running on the same.
Oh, now it's running on your account. Your Martin account.
But, yeah. Okay, where are we? Where's this? Clean your first model. Running your first notebook. I think that's where it was. Yeah. There it is. Okay, I'm gonna try. Let's see what happens. So now we have 2 instances running. Where's the other one? Right here. Okay, so this is the one we started first. And then this is the one we started later.
Cool.
And this is still, this one bar is still at 0%, which is kind of worrying. Look, it's been running for 33 minutes, I think.
But at least that one, that one looks like, I don't know if it's done, but now, I don't know if that data was there before. I don't remember.
What data?
Epoch 0, train loss 0.18145, that, what you just highlighted. I don't know if that was there before. So maybe that just finished. I don't know.
That doesn't have anything. That's still download. Yeah, I think you're right.
Yeah.
This doesn't say anything at the start.
Yeah, so maybe it just finished the first, I don't know, whatever. Let's go on.
Maybe it finished Epoch 0 and it trained for Epoch 0 for 33 minutes. That would be crazy if it's going for 92 epochs. Maybe this is something else though.
No, I don't think that that's what that is.
But it looks like Epoch 0 had a train loss of this, had a valid loss of this, had an error rate of this, and trained for 33 minutes.
Go back, go to that last tab. Or just open up a new tab of this.
Of what?
Of that same Jupyter notebook.
Additionally to this one?
Yeah. Just open up a
Okay.
new one. And then go all the way down to where the sample output would be. Running your first notebook. Yeah, so it's so funny.
14 seconds.
Yeah, right.
That's ridiculous.
Can you put this URL in
Maybe
in the Twitch Slack or Zoom or whatever, and I'm gonna try it on my computer?
Yeah.
Maybe it's the internet connection.
I'm gonna put it in the Zoom chat because I don't have Twitch open.
All right.
Somewhere. I guess I have to stop sharing. Coming up. Okay. Yeah, so maybe it's running on my MacBook actually, or what?
I don't know.
That would be weird. But if this takes 14 seconds, and we trained for the first epoch for 33 minutes, that's like. Can you share your screen so I can watch it do stuff?
Yep. Oops. Oops.
Yeah, that second instance that I started seems to be doing similarly to the other one. It's like at 8% now of the first whatever.
Mm-hmm.
It doesn't look like it's much faster. Definitely not 14 seconds.
Oh, I have to do this.
Well, don't share your code.
Yeah. I mean, you still see it here, so whatever. Did you have to push enter or something?
Yeah, you have to press enter.
Okay. And then what was it? Your first...
The first model. Mm-hmm.
It's gonna be it'll be funny if it really just it really does take like 14 seconds for each one.
We did most of the quiz in a like not very good way also because we didn't use the cards. Or maybe it's really, yeah.
Let's see.
Otherwise, I guess we can keep it running. Like we can stop the stream and keep it running.
We're just using all of Google's resources to train cats and dog models. No, it
in
seems
case
like
anyone's experiencing like lags in Google search, this is probably because of us doing this training.
No, it seems like it's taking just as long. I'm gonna stop it on mine.
Yeah.
Oops.
Interesting. 71.
All right, you could go ahead and share again if you want.
Yeah, and I guess I can stop the other one too, huh? Like that's the second one I started. And
Yeah,
it's
I mean,
at
if you want to
20.
keep it, I don't know, if you want to keep it running and
Yeah.
see, let's finish,
Yeah,
I
let's
guess.
see.
Yeah, let's go through the
Let's
rest of this.
see, maybe this one. It's at 67. I guess we can keep it running until
Maybe
it's
that'll be
done.
the last one. Yeah.
I think so, yeah, because the other one had 2 written here, right?
Yeah.
So I guess this is gonna run, then the second bar is gonna run, which is faster, and then we're gonna have this, I think. Oh, we'll see. Okay.
Anyway, all right. So what's the next
Just
question?
Baseball. We know how to learn baseball. How does it compare to regular programming? Oh, no, let's see the answer to this. Machine learning is just like regular programming. Is just like is a way of telling computers what to do, but instead of telling the computer exactly how to carry out the specific tasks, we write a program where the computer can alter some parameters based on the training samples show it. In this process called training, it arrives at an implementation that hopefully will perform well. Okay, nice. That's what we decided on.
Yep.
ML jargon. What do we call? Is it jargon? Is that how I say it?
Yep.
Jargon. Okay. The functional form. The functional form of a model is going to be the
architecture.
Bam. The weights.
Parameters.
Parameters. Results.
Loss.
Predictions.
Or predictions.
Measure of performance. No. Loss.
That was the loss.
Yeah. Dependent variable.
Parameters.
The labels.
Dependent variable. Yeah.
Yeah.
Is it targets? What is targets?
I think that's the labels. Functional form architecture, weights parameters, results predictions, measure of performance loss. Yeah.
It doesn't say targets anywhere on there. But anyway.
The why targets aren't labels an equally, if not more common name for the dependent variable, while the term label is popular and applicable in the context of classification, as the animal, image, or cat or dog. Labels considered a specific type of targets. Okay, but as we continue, we will start to encounter models that can predict many other things, for instance, numeric values. What is the age of a person in this X-ray? Or perform some other tasks such as predicting the ID. Okay, cool. Spot on. What is positive feedback loop? Incarcerations.
Positive. Wasn't this like when you just go down the rabbit hole of down a rabbit hole of a bias?
Yeah, not necessarily a bias, but it's like something that feeds back into itself and supports the initial thing to then make it even stronger. It's a positive feedback loop. Yeah, but that was the example. Yeah. In which the more model is used, the more biased data becomes biased. Okay, making the model even more biased and so forth. Okay, that's too spot on. That's the most important thing to do in the top-down approach to learning. I don't know. The most important thing to do is we will run a lot of experiments. A list of useful things to do before the second lecture includes: make sure you can spin up a GPU server that you can shut it down when it is finished. Run the code shown in the lecture. Use the documentation. Use the doc function inside Jupyter Notebook. Do some searching. Okay. Wait, I'm confused. How is that related? Because that's how we do.
Oh, this is just the last. It's 9 out of 9 for the first lecture. So okay. Whatever. Let's just go to the next one.
I don't know.
We should have maybe just wait. Is this lesson 2, or go back?
Lecture 2, yeah. That's lecture 2. I guess we're not there yet.
Or is lecture 2 still part of lesson 1?
No, lecture 1, lecture 2. It's a different one.
Go to the first tab, Fast.ai video.
Yeah, they got more questions here. They didn't take all of them. Yeah. They were like, no one needs to know this. Everyone knows this. So this one was the one we were interested in, right?
Yeah.
Okay, wait. So this didn't... Pixel...
No.
Before. Okay, they didn't take this one over. Image size. No, I searched for that already. Let's see. Maybe Google knows it. I'm sure a lot of people went through this course already.
That first one looks pretty good.
Change input shape dimensions for fine-tuning. That's very interesting. Can you change input shape of images after training model.
It's the most ridiculous Google searches.
What? Is that not how you Google search?
No.
How do you search?
I would search. So you want to know? Can you change input shape of images
You would
after
do
training?
shape, not change.
I would
image.
do input.
You would do like that. Change image. Quotes shape. Train. Model. Like that. Is that what you would do? So we get to the same result.
Yeah.
The same result.
I don't use quotes though. Is that
you don't?
I feel like maybe Google does put more weight on those quotes.
No, if you put the quotes, then it needs to appear like that. Like it can't. Otherwise, it splits up the words totally. Like it just takes them anywhere. Yeah. Shape. Photos will have to be reshaped prior to modeling so that all images have the same shape.
Did you ever look up the word recursion on Google?
Yeah, I have.
You did? Okay. It's a fun one. Oh wait, no.
Wait.
What is recursion?
Did they take it out?
Oh my goodness. This is so sad. I still see it.
Wait, what? Show.
Just recursion. Just the word recursion.
Show it. I stopped my share. Is that difficult? Like, do you have to like switch between different screens or what when you share?
It's kind of annoying because I'm on another monitor. But
yeah, okay, then don't worry about it.
For the sake of our users, I'll do it.
Okay.
Where is it?
That's you, Justin. Justin's not there.
I don't know that he's still here.
I don't think so. It's also late. I hope this thing is soon over so that I can go to bed.
Did you mean? And then do you mean recursion?
88.04%.
And you can just keep clicking this.
Interesting. Yeah, why is it not showing up for me?
I don't know.
I don't know.
Anyway.
Recursion. You know why? Maybe because I'm in Ukraine.
I could
like
be.
maybe it's maybe it's something that only happens on Google.com. I'm on Google.com, but it's really not showing up. Maybe it's a US only joke. Something. So, but anyways, so the input images. Wait, so the training images have to have the same size for sure, all of them. But then do the ones that you're predicting on also have to have the same size? I guess is our question, right?
I don't think they do.
Reshape them. But usually train and
no,
test.
it was reshaped for training, not predicting in the Jupyter notebook.
Cat resize training. Yeah, I mean,
it was resizing it, and yeah.
I don't even know whether we're going to do some like where the prediction happens here. Like we're just making the model here, right? I don't even.
Yeah, it's just fine tuning a model. It's very.
Are we even going to see anything?
No. We're gonna get another. We're gonna get 2 rows of this another. It's gonna be epoch 0. A train loss of something, a valid loss of something.
And another half an hour of training.
Yeah, that's all it's going to be.
All right. That's anticlimactic.
Yeah.
I guess we should at least show like a nice picture of it, of your puppy maybe.
Yeah, maybe we'll put just Google dog.
Okay.
Oh no, it's not even training dogs, it's training cats. Let's just find a photo of a cat.
And it's cat. Right.
Oh man.
Well, interesting. I guess so it's just the input is just dogs and cats, and it's just trained on identifying cats, I guess, right?
I guess so.
Yeah, probably. So then it's like if it's not if it classifies it as a not cat, then it's going to be a dog because that's the only input it has. Anyways.
I don't know.
Okay. So we still don't know that. Do we always have to use 2 to 4 pixel
No.
images with the cat recognition model? You think no?
No. I
we should
saw
post
something
it in
on
our
your
chat.
screen. I saw something on your screen before. It was like you can use different. I think it's as long as it's small and a square. But maybe it has to do with the number of pixels as well. I don't know. What's on your the last tab? No, not this one.
Trained.
Second to last.
That
one. 224, 227, 299. So.
Francesca asks a great question. Do you know of a good blog
But what's
on a data that has a smaller shape than
wait, hold
that
on,
shows how to inlet transfer in the data?
Go down. What if you wanted to utilize pre-train for transfer learning? What different image dimensions? Then what the CNN trained on, and increasing their size introduces too many artifacts and dramatically hurts. Okay, so typically you want it to be as small as possible, but introduces too many artifacts and dramatically hurts loss accuracy.
No, I think it's just, I think generally you want it to be the same size is what I take away from this. Like if it's smaller, you get this problem. If it's bigger, you get this other problem. No.
Wait, hold on. There are two common reasons like why you would want to have a 224. Your input image dimensions. So the reason why you would want to is they are considerably smaller than what the CNN was trained on.
Yeah.
Hold on. Why you might want to utilize different image dimensions.
Mm-hmm.
Increasing their size introduces too many artifacts. Okay. Small objects that are hard to detect. Resizing to the original input dimensions of the CNN hurts accuracy. You postulate increase. Okay. You would wish to update the image shape dimensions of the CNN? Okay, so it is possible. I didn't really get anything from that. What's the next question?
I think it's not recommended. I think that's the answer.
Okay.
I mean, maybe there's a way. Maybe you don't always have to. But is
this it for lesson 1? Like.
Yeah.
Okay.
What do you mean? Oh, good question. Yeah, I think. I think it's this notebook. I'm not sure what. Yeah, now we're on this 24 thing.
Tune in next week for the results of lesson 1.
I mean, there's a lot of stuff we can read over, you know. Maybe we should do it. You know, like this is really long. There's a lot of. Look at that.
Yeah.
It's not just for image classifications. We can run something else that's going to run for half an hour and predict whether it's a person walking or a car. Yeah, there's a lot more we can run, but I'd suggest we do it not today.
Yeah. All right.
We're going to wait for this to end so that we have our boring end to it.
All right, so you want to keep it going until that ends.
Yeah. I think that's because it's going to be such a dramatic.
Our first stream is going to be a 24-hour stream.
Oops. No, it is nearly done. I mean, if it's going to start another loading bar, then I'm
I don't know.
out of it. Okay, we still have 2 questions down here. We don't really have an answer for that. How can we find a better answer for that? I guess we could watch through this.
So I think with the cat recognition model, I think the answer for that is yes, because that's what the architecture calls for.
Yeah.
I think the answer is yes, because that's what it was trained on.
I think so, yeah.
So
Okay. What is the difference between classification and regression? classification and regression. I think regression is like the thing it runs, and the classification is what it does.
Yeah, that sounds right.
Okay, next.
Next.
Our pop quiz is taking 2 hours. What is a validation set? What is a test set? Why do we need that? Nick.
Validation set is what you would run against a trained model to check that it works, and then a test set would be something that, like a new set of data that you would run.
So what would the validation set you already have? You know the answers? No, isn't that what the test set is?
That's what I'm thinking. Like a validation set would be a set of a set of data that was not used to train the model, but you know the answers to, like you know that they're all cats, for example. And then a test set may be a set that is with I don't know.
Why would that be a test then, if it's like new data?
Yeah.
A validation data set is a sample of data held back from training. A validation set, sample of data held back from obtaining a model.
Yeah. This is something that, like, so I remember this now. So the validation set is, it's, so for, I did this for the like stock price checker or stock price predictor, where you would train the model on a year, right? But you only train for the first 11 months, and then you test on the last month to see if it's actually, if the previous 11 months are a qualified predictor of the next one. That was a validation set.
And what's the test set then?
Oh, I don't know.
Okay.
But I just saw the first line, and that's what I think it is, right? A validation is different from a test data that is also held back from training. Instead, used to give an unbiased estimate of the skill of the final tune.
Give an estimate of model skill while tuning models hyperparameters, and the other one is after the tuning is finished. So yeah, so I guess maybe each epoch when it runs, when it does the tuning, it uses the validation set to figure out how good it is in each run, and it decides depending on that whether it should continue with this one or try something else, discard it, right? And then
the validation set is used. You run the model on the validation set after the model is trained.
No, I think.
And then you go back and then you adjust, and then you adjust the weights, or you adjust the parameters to retrain the model so that it works on the validation set. And then the test set is something that is completely out of, like, that's what it's saying here. It's like confusing, and I think it's kind of hard for me to articulate this too, but it's something that's like completely taken out from what would be in the set.
Like, it's not used for building the model. Like, it's not used for deciding whether the model is working well or not. The test data set is just used at the end to decide, like, what's the accuracy or whatever.
Yeah, like the validation. Yeah, the validation set is used to fine tune the parameters, and the test set is after you fine tune the parameters, you run it on the test set and you see if it actually works. Yeah.
Or how well it works. Yeah.
Right. Cool.
Okay. Yeah, I think I agree. Ooh. Look at that. Our first run took 33 minutes. The second run is finished and took 49 minutes.
All right.
And now what's now? Now we're done.
Now we're done. Thank you very much for watching this stream.
Here's a cute cat. Goodbye.
Here's a cute cat. Goodbye. No. What was the last question? Because I think we have one more question.
You're right. What will Fast.ai do if you don't provide a validation set? Probably not run.
Probably. I'm okay leaving it at that. No, I think if you don't provide a validation set, it's just going to train it on what it has, and that's it. It trains it on the data you give it. I think adding a validation set just adds the ability to fine tune.
Hey, so do you want to try for next time for next time streaming? Like, this is fun. I think let's do more of it, but maybe we should like watch the video separately and then we can talk about it.
Yeah, that works. So you want to watch lesson 1 and lesson 2, and then we'll.
Yeah, and then we can do a quick recap on lesson 1, and maybe what do you think about that?
That sounds good.
Until like next week.
Yeah. We could also like talk about this more outside of the stream. Do you want to do anything else for this now?
Please like and subscribe.
This isn't YouTube. Smash that like button, hit the subscribe, hit the notification bell. You guys know what to do. Yeah, I don't know what the.
Let's go. Yeah, let's. So we did this up to here. Like, there's so much more in this notebook. Also, maybe we could go over it next time. Some more.
Yeah.
And we hope that this training is already done. Maybe we don't have to retrain or something. Could be.
Yeah, could be.
Could be that the model's saved now somewhere, and we can use it to play around.
Just don't X out this tab.
I'm gonna keep it open forever.
All right,
okay.
Cool. Yeah. Sweet. So I guess we can put up like a
what?
Like a calendar or something for like a stream, somewhat of a stream schedule on our channel.
Yeah, we could do that.
You know what we should do for the next one also? We should just read through the We Are Hazard stream, first time streaming insights, and do this properly.
Yeah.
So let's do that. All right, cool.
Let's get prepared.
Yeah.
It was nice, and it worked.
Yeah, this worked.
Good job debugging the audio.
Yeah, I'm not touching. I'm leaving my computer here and buying a new computer, just so that I don't have to set up the audio again. All right, cool. I'm gonna close the stream then.
Yeah. Bye bye.